everything said is correct, but when you just say a bunch of correct things, it doesn't necessarily make it correct. Okay. Okay, so this question is asking what the magnitude and direction of the current in the 20 ohm resistor. So first I'm just going to sketch it out here. So so this one's a fairly simple Kirchhoff question. And so we've got a 9 volt here, a 6 volt here, a 10 ohm here, and a 20 ohm here. So this is the resistor it's asking about, so it wants the magnitude of and direction of the current. So to solve this, so whenever you see multiple batteries, this is a good sign that it's a Kirchhoff law question. And so we need to essentially make a loop. So we're going to go from A to B to C to D and then back to A again. And now whenever we pass over a resistor, we're going to generate an equation. And so it'll be 0 equals, and whenever we pass over an equation, so in this case 10 ohm, or whenever we pass over a resistor, in this case 10 ohms, we're going to go minus, this will be minus IR1, so that'll be the current through the resistor times the resistance. And also recalling that your current either will be maintained, like in this case where you have one loop, or if there's splits, the current will split based on the resistances in the split. In this case, we only have one loop, so the current will be the same around the entire thing. So we can just use IR1. And then the rule for going across batteries is if you go from positive to negative, then it's minus the voltage. And if you go negative to positive, then it'll be plus the voltage. So A to B, B to C, C to D gives us minus IR2. Or I guess I might as well put in the values since I'm putting the values for the voltages. So this will be 10 ohms. And this will be 20 ohms. And then going from D to A, since we're going from negative to positive, is plus 9 volts. And I should have said that when you go over a resistor, it's minus IR as long as it's in the direction that we're going. So in this case, we're going this way, this way, this way. As long as the current is flowing this way, I should say. So in this case, we're assuming the current's going clockwise. And so each of these resistances get negatives. If the current comes out to be negative, that means we assumed wrong and the current's actually the other direction. Okay, so now we have our equation and we can solve it. So we've got 0 is equal to minus 10I. And I'm just going to collect things, so I've got a 20 over here, so that actually should have been a minus 30. And then we've got a minus 6 plus a 9, so plus 3 volts. That's still an ohm. And so our current is minus 3 volts over minus 30 ohms. Negatives cancel, and that's 1 over 10 amps. Okay, so the current comes out to be positive, meaning our initial assumption that the current was clockwise was correct. And so, and that's our value. So the current through the 20 ohm resistor is 1 over 10 amps, and it's going to the left, or it's going in a clockwise direction. Okay, so looking to the solution here, applying Kirchhoff's rule, we get this equation, assuming a clockwise flow. We can solve for I, which gives us 0.1 or 1 over 10. And since it's positive, our clockwise assumption is correct. And so that's what we get. And so the solution is correct.